Okay, today I want to explain about the objective. The objective of the project is to design a stable product that affordable to the farm, to create a new product that can help farmer in agriculture. Next, the scope and limitation of this project. First, use for the solid fertilizer. Second, the container limited to 5 kg of fertilizer. A significant of study. Nowadays, one of the industry that contributes of the national economy is the agriculture sector. In our national, many different crops are planted. The garden's outcome, however, are not promising according to what I've seen. Farmers continue to apply conventional techniques by hand planting fertilizer. The fertilizer applied to each tree would not be same for all them. As a result, each tree produce a different result. The purpose of this project is to develop a smart fertilizer container that will allow farmer to measure and apply fertilizer at the same rate to all trees in the same amount. Farmer will then make more money. In summary, this research open the door for the future research by other scholars that will benefit farmers in Malaysia. Next is identification of need. I will be explained by using a table. So for this project, my title is Smart Fertilizer Container. So for the introduction, design problem. Due to heavy weight during a fertilizer, the operator feel very tiredness. So intended purpose to fertilizer constantly. I intended me can participate to the soil of a plantation. Special force is break the fertilizer spraying from the excess. Customer requirement. Functional performance can carry a large tank that contains a 5 kg of fertilizer. Semi-auto of nozzle. So operating environment, flat crop area. Economic should have a economic life more than 4 years. Maintenance, repair and retirement. No repair should be required for the first year, since it is very easy to use. Reliability, no failure should occur during economic life. Safety, no sharp corner. Pollution free of the carbon emission. Is to use simple to fill the fertilizer solid to the tank. Simple to adjust the nozzle height. Easy to assemble, need only a few minutes. Easy grip handle. So for the human factors, easier and the less force required to use. Appearance, surface finish should be smooth to facilitate cleaning. Shape should be consistent with the current trend. Marketing, retail price should be less than 150. Costing, development cost is 200. Constraints, and for the one, this product cannot be used for highly areas. For the two, the sprayer are fixed and not flexible. Customized certification. One is a comfortable handle. Second is self-appropriate sprayer. For the background research, there are no tools or machines that are used for farmers to sow fertilizer to their crops. They pour fertilizer into a container. They sow fertilizer into the container. The farmers have to sow fertilizer to the crops using the traditional method, which is by hand. This way, the farmer cannot sow fertilizer with the same quantity to each plant, and the result can be seen when their trees do not grow well because they not get enough fertilizer. Sometimes farmers sow at a lot and sometimes at a little because they only play a little bit to sow fertilizer. With this product, they can give the correct measurement and the quantity of fertilizer used in each tree is the same. For example, the farmer set 200 grams for each, so other tree will also get the same quantity. The tree growth will be even because the plant receive the same quantity of fertilizer.
So now I will present about the conceptual design. So the conceptual design is the framework that establishes the aim and the idea behind a visual layout. For product concept development, at this point, several different conception for each sub-function of product component decomposition has been produced. The morphological matrix is one of the method for generating this alternative notion. So as we can see in the table, this strategy begins by listing the sub-assemblies in a matrix column and the alternative concept for each function in neighboring rows. So for the first part, which is host, we come up with three alternatives, which is first carbureted water rubber hose, and air hose. So for the nozzle, we got flat nozzle and streaming, and the flexible part, which is back, wheel and chain. So next is the alternative concept evaluation and selection. So once various concepts have been created, the most appropriate concept must be chosen to meet the requirement outlined in the product design specification (PDS). To begin with, some of these options will be dropped if they do not meet customer wants or not practical to build. The figures below, the figures also depicts the conceptual design for the remaining chooses as potential candidates. So these are the illustration aid in visualizing the rough framework of the alternative for the following review process. So we can see at the first and the second design are quite similar, but there are difference in part, which is we use different hose and different nozzle, and our chosen design is design 3, which we can see there are additional parts in the nozzle area. There are weight sensor and they are stick to allow the fertilizer to from our container. So lastly is the weighted rating method. So based on the three design, we rate the design based on the efficiency, reliability, the maintenance, the cost and the weight. So we can see from the weightage rating method, the third design get the highest mark, which is 3.55. So that's why we choose the design 3.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Hamzah, and I will present about embodiment design. So, I'm gonna talk about dimensional modeling. So as you can see, option 4 is further drawn as engineering drawing and modeled via SolidWorks. The design is based on average body height in Malaysia. The project consists of components: container, knapsack, rope, hose, nozzle, weight sensor, and stick. The length of the component is considered for the convenience of user, and the container is 52.5 cm in height and 44.8 in length. So the next thing I'm gonna talk is material selection. So in this section, only some general assumptions are made based on basic properties and general usage of the material. Three main things during choosing material, which are the material need to meet the performance requirements, the material is easy to process, and the material have right aesthetic properties. Material selection charts can be used during this stage, such as Young Modulus Density Chart, Strength Cost Chart, and Metal Stiffness Density Chart. So this is our metal stiffness density chart. So as you can see, this is our strength cost chart. So based on this chart, can be concluded that the strength of ceramics is only sufficient for loading in compression. Ceramics would be not strong enough in tension, woods may be strong enough, while composites might be too expensive to use. Metal here appears to give good overall performance, but we go with plastic because project is not used for extreme activities. Lastly, I will present about analytical design analysis. There are three techniques to forecast how well a prospective design will perform, which are analytically, experimentally, or using both. So, we decided to find the pressure for the user using the formula P equal to F divided by A. So, we can conclude that the pressure for the user is 1.533 times 10 power of -3 Newton meter. So that's all from me. Thank you.
This is our full design in using SolidWorks and size of smart fertilizer container in isometric drawing. For bill of material, the part of smart fertilizer container we have body, rope, hose, stick and nozzle. The process for producing a nozzle is design and prototyping, material selection, cutting and shaping, surface finishing, assembly testing. It worth nothing that the process can differ depending on the type of nozzle, the material used, and the specification required. Some nozzle can be 3D printed or produced through injection molding. The evaluation cost. The first part is body. It costs 98 ringgit. The rope it costs 7 ringgit. The hose it costs 10 ringgit. The stick it costs 1 ringgit and 60 cents. The nozzle we estimate it costs 4 ringgit. A prototype is a preliminary version of the product or machine used for testing and demonstration purpose. In order to prototype a smart fertilizer container, we would first need design and build a working model for machine. It would likely involve selecting and resourcing the necessary material, as well as programming and any electronic or computer controlled component. Once the prototype is built, it can be tested to ensure that it functions as intended